Hey everybody, thanks for checking back in. I hope everybody is doing well. I wanted to touch base about a few things before we get into this next lesson. The first thing I want to talk about is kind of the goals and expectations. Maybe it's time I revisit this. I want you to remember during these remote learning days, this is not normal. It's not normal for teachers, and it's not normal for students. It's not normal for parents. So because I am aware of how stressful this is, and because I'm aware of how very easily you can be overwhelmed working at home on your own instead of with help in a classroom, I want you to understand that my expectations are different, right? All I'm really asking you to do anytime I present a video or anytime I ask you to do a couple problems, I'm just asking you to try. I'm asking you to do the work and to try. So if it's a video, just watch the entire video. You have to watch 100% of that video in order to get the point. Some of you have been only watching your video to like 80 or 90%. I don't give a point for that. You have to let that video play all the way through. And same for problems. If it's a day where I give an assignment, right, I just want you to try the problems. I'll never give you more than 15, ever. Maybe even more like 10. But some days I'll grade them for accuracy, but you still get the point. And other days I'll just say, yep, I got your assignment, you get the point. More than anything, I really want you to communicate with me. If you feel like you are buried and you're drowning in math, although I really have tried hard to structure this so that you're not drowning in math, shoot me an email. Let me know, Glessner, I can't do 10 problems in one day. Like, I don't know. I feel like you can, but especially in an accelerated class. But communication is going to be key, okay? So I just want to get that out there. Be sure you're emailing me with any concerns. I just want you to try these concepts. I'm not expecting mastery. It would be so much different if we were in the classroom together, right? But we're not. So we just have to do the best we can. All right, guess what? We're moving on to Unit 7. Unit 7 is titled Polynomials and Factoring. So that leads us to today's actual video lesson, which is called Polynomials. So let's get ready to write some notes. Here we go. What is a polynomial? It is an expression consisting of many terms. You've already worked with polynomials this year. We just didn't call them polynomials. All right, now there's this thing about polynomials in math. They're real picky about writing them in a certain order. So check this out. They like polynomials to be written in standard form. Here's what standard form means. Your polynomial is written in alphabetical order. I'm just going to call that alphabetical order with regard to variables. You'll see in a minute. With the highest exponents first. So standard form, it's actually kind of a big deal, and it's gonna, if you get used to it, it's gonna simplify your life moving forward as we work with polynomials and factoring. All right, here's an example of a polynomial. This says 2x to the third plus 5x minus 4x plus 7. The highest exponent is called the degree. So if I were going to name the degree of this polynomial, since 3 is the highest exponent, boom, right there, that would be the third degree. And it's going to actually have a name more than that. But when you go to decide the degree of a polynomial, you have to first have it written in standard form. And from there, then, you find the highest exponent value, which in this case is a 3, and then you're going to name it based on that. So let's talk about. There are 2 ways that you're going to be classifying your polynomials. One of them is by degree, and the other one is by the number of terms. So back to this example up here. It's written in standard form. The highest exponent value is 3. You come down on this chart. A 3 is called cubic. So we would call this polynomial a cubic polynomial. And then how many terms does it have? Well, it has one here, and this is another, and another, and another. So that has 4 terms. If it has 4 or more terms, it's a polynomial. So this is called a cubic polynomial based on these 2 classifications. Okay? So let's look at this chart. You should definitely write this down. If your polynomial does not have any exponents, or I guess I should say it doesn't have any variables with exponents, it's a 0 degree, and you would just call that constant. If you have a variable and the highest exponent is 1, that's considered linear. If the highest exponent is 2, it's a quadratic. 3 is cubic, and 4 is quartic. And from here then, of course, your number of terms. If it only has 1 term, it's a monomial. 2 is a binomial. 3 is a trinomial. And 4 is a poly. Poly means many. So a lot of this is just understanding prefixes, right? So just don't forget that when you're classifying polynomials, there's 2 ways to do so. So let's practice. Here we have a 6. Question is, does it have a variable with an exponent? The answer is no, it does not. So this is considered one of these 0 degree ones. So it's a constant. Now, that's its degree. Now, how many terms is it? It's 1 term. That's a monomial. Cool. How about this guy? Does it have a variable with an exponent? Yes, it does. It has a variable of x. The exponent is the invisible 1. So it is linear. How many terms? 1 term. It's a monomial. How about this? Variable, yep. Exponent, 1. So it's linear. How many terms? 1, 2. 2 terms is binomial. How about this guy? Does it have variables with exponents? Yep. What's the highest degree? This one, and it's a 2. 2 means it's quadratic. How many terms? 1, 2, 3. 3 terms is a trinomial. This one, there it is. The highest exponent is a 3. That makes it cubic. 2 terms is a binomial. Holy cow, look at this guy. Okay, the highest value exponent is 4. How many terms? 1, 2, 3, 4. Polynomial. If I could spell it, N-O-M-I-A-L. There we go. So that's how you classify these things. Now, from here, I'm going to teach you how to write them in standard form, and then we're going to practice adding and subtracting them, okay? Standard form. Standard form, this can get a little tricky, so stick with me, and we're going to do all these examples. Don't forget, it has to be written in alpha order as far as your variables go, and the highest exponents go first. And it gets a little tricky down in like number, let's say 11 and 12. So just watch what I do. Here we go. Alphabetical order with my variables. Well, I only have x's, okay? So this one has an exponent of 1. This one has an exponent of 2. This guy, he is the leader of the pack. So that term is a positive 2x squared. He comes first. Now, who comes next? This x term with an exponent of 1, and that's a plus 3x. So we've done this guy, we've done that guy. So who's going to come last? Your constant. He has no variable with an exponent on it, so it's just plus 1. So you're going to find that your constants come last. Okay? So now I bet you could tell me that this is quadratic trinomial. Quadratic because the leading exponent there is a 2. Okay, the next one. This says x squared plus 64 minus x, which really has a 1 on it, and plus 7x to the third. Okay, so they're all x's. That keeps it simple. And the highest exponent value is the 3. So that is my leading term, positive 7x to the third. Exponent of 2 comes next, so it's plus x squared. An x with an exponent of 1, that comes next, and that's minus x to the first power. And last is the constant of plus 64. My marker's dying. I better change colors. Cool, let's keep going. The next one, number 9, has all x's. It's a 3, it's a 2, it's a 1, and it's a nothing. So it's almost in standard form. X to the third comes first. Plus 5x squared comes second. Minus x to the first power is next. Do you have to show the 1? No, you do not have to show the 1. I just am showing it so you can kind of see the progression of the exponents. And then our constant of plus 28 is last. Number 10, no exponent or no variable with an exponent. X of 3, x of 1. This guy is the lead term, minus x to the third, plus x to the first, and plus 24. Easy peasy, right? Okay, that's not too bad. Well, it gets a little interesting here, so pay attention. Now we don't just have like x's. We've got AB, A squared, B squared, and B to the third. Okay. It's alphabetical order, and within that, you have to also pay attention to the exponent. So, who would come first in the alphabet? A. Not AB, A. Single, powerful A. And there are no others, so A to the third is our first term. He's the most powerful guy here. Cross him off. Now, who do you think would come next? Do you think it'd be ABs or Bs? It's ABs. Now, we have A1, B1 right here, and we have A2, B2. Who do you think is more powerful, A2, B2 or A1, B1? It's this guy, A2, B2, right? He has higher exponents. So he's our next term. Then this AB, they both have 1s. And finally then, the very last guy would be just the plain old B. Well, it's B to the third, minus 2B to the third, right? So the A's, then the ABs, then the B. All right, this is kind of like the middle ground between the A and the B in the alphabet. Think of it that way. Okay, let's do number 12. I see X3, Y3, X2, Y2, and this guy's got nothing. Most powerful. X comes first in the alphabet. Then you would do your X2, Y2. Then you'd get to your Y's. And finally, your little constant. Right? Okay. Cool. Couple more things before I turn you loose here. I'm going to teach you how to do some adding and subtracting of polynomials. And for this, I'm actually going to switch to paper. Adding and subtracting polynomials. You should write this down. So this is adding, obviously. And basically all you're doing is looking for the like terms. Now I'm going to try to color code this, but I know the colors don't really, they don't capture well on this document camera. So we're just going to do our best here. Honestly, part of me wants to tell you to put them in standard form first. The other part of me says you can put your answer in standard form when you're done. If you want to rearrange this into standard form, you can. And make sure this is in standard form. And then it'll be kind of easy to match up your terms. You don't have to do that. If you want, you can just look for who goes with who now, write your answer down, and then rewrite that in standard form. Here's what I mean. 18x, okay? We're going to add that to any other x's over here. So I see 18x here can go with a minus 8x there. They are like terms. So what's 18x minus 8x? That's 10x. And that's light blue. Hopefully you can see that. Next up, x squared. Are there any x squareds here? Yup. So we have a minus 2x squared, or if you want to think of it as a negative 2x squared, whatever. Adding that to this positive 3x squared. So if you have negative 2x squareds and positive 3x squareds, that leaves you with positive 1x squared. That's an orange. Hopefully you can tell. And what's last? Constant of 15, and adding that to a constant here of what would be like negative 10, 15 and negative 10, or 15 minus 10 is plus 5, and that's in green, right? So you're really just combining like terms. Easy. Let's do a couple more. I'm going to give you a long one. Uh-oh, you know what I just remembered? I didn't make you put that in standard form. We're going to go back and do that as soon as I finish writing this. Okay. We're going to back up for just a minute and rewrite that first example up there in standard form. I bet you can tell me who would come first. Who's most powerful here? This guy. Then who? This guy. And finally, your constant. That would be the ideal answer in standard form. Sorry. And if you want to show that one of a coefficient, you can, but you don't have to. Sorry about that. Okay, look at this one. I'm going to say we're going to do this, and then we're going to move into some subtraction, and then we're done. Okay? Here we go. Like terms. Let's start with light blue. X to the third. Hey, there aren't any. This guy just stays. Nobody else like him. What's next? 6x to the second power. Oh, there's another one. 6x plus 4. Okay, we got 6 of them. We got 4 of them. That makes positive 10 of them. Cool. Who's next? I see a constant of 18 and a constant of 8. Those guys go together. Negative 18 and a plus 8 makes minus 10. I'm trying to think if I need another color here. Yes, I do. I need another color because see this guy out here? He's a plain old x with like a exponent of 1. So minus 24x. Now we can put it in standard form. Who's the biggest? This guy. Then the next guy is orange. Then this guy. And finally, this little guy right here. Okay? That's awesome. Oh, that's your final answer, by the way. I guess I should box that up. Okay, so that's adding. Now, Subtracting. Okay. Subtracting gets a little tricky. Subtracting. Let me just show you. Okay, here's an example. We're subtracting. Here's the deal. You have to do one of two things, and chances are you're going to be better at one than the other. Either you have to remember that you are taking whatever you're starting with here, these terms, and you are subtracting whatever this says in here, which isn't too tough right now. But when we start having negatives in here or subtraction within here, subtracting a subtraction is like addition, right? And kids notoriously kind of mess this up. They forget that they're subtracting what they have in here. So my suggestion to you is do this first. Think of this as, cover that up, a -1 sitting out here being multiplied by this piece and this piece and this piece. So if you were to multiply a -1 all the way through that expression, you would now have -10x minus 3x squared and a -2. If you do that, it can turn to addition. That's my suggestion. I'm just going to tell you, you're going to have more success that way. I promise. Okay, I'm going to rewrite the first one because it bothers me not to do so. Okay, here we go. I'm going to make this super quick, and then we're probably going to do just one example. Okay, after this, we do one more, we'll be done. Let's get going. Who's this guy? 6x squared. Okay, x squareds. Are there any other x squared? Boom! And look, it's a -3x squared. So 6x squared minus 3x squared is 3x squared. Telling you, I like changing this situation into this situation. I just think kids do better with that. What's this guy? That's an x. Hey, this is an x. So I've got a positive 7x and a minus 10x. That makes -3x. Who's left? This little guy sitting out here, -2. Hey, guess what? Good news. It's already in standard form. Yay, standard form. It was done for us. We love that. Let me do another one. Let me pick a good one. Ooh, I have all these problems to choose from. You're like, hurry up, Westner, just pick one. Okay, let's do this one. We're going to do, if I can copy it down correctly, my eyesight isn't so good, you know? Look, write this down. Minus there it is. No me gusta. I don't like this. I don't like this because you will forget that it's going to eventually say -4 minus -4, which is really +4. I'm telling you, think of that as being multiplied by a -1 and change all of your terms. Do that. Okay? This guy doesn't change. And now you get to combine them or add them. Okay, ready? Here we go. I see an x squared. I'm going to put them in purple and boom, there's an x squared. So this is 1x squared minus 1x squared. 1x squared minus 1x squared. That means they go away. They cancel out. Peace. Sayonara, x squareds. What's next? A plain old x term. There's a plain old x term. So I've got 6x, which is positive, and a minus 6x. They also cancel out. Peace out. You're out of here, right? They canceled out. They go away. What's left? We have a negative 4 and a plus 4. What? Negative 4 plus 4, they cancel out. Would you believe that? When you subtract these, your answer ends up being 0. Oh, that's crazy. Do you feel like we need to do another one? Can we do one more? Okay, I know it's getting to be a long video, but I really want to do this last one, okay? I'll try to do it without talking too much. See if you can just follow along. Six minus 4. Negative 3 plus 2. What do I want? I want another color. Negative 5 minus 3. And it's already in standard form. Awesome job. Okay, so we're going to spend some time practicing with this before we move on to do more things. All right, thank you for watching. Don't forget to email me with any questions. Take care, you guys.